All right, when we're looking at applications of trig functions, you're really looking at how can I graph what I'm already given. Now, a lot of the times you'll be given the maximum and minimum in a question, or the period in a question, or some variation of the equation of the axis by the maximum and minimum, or the actual equation of the axis depending on the word problem. If you look at these formulas, so we talked about the amplitude being the max minus the min divided by 2. Our k value, if we're dealing with degrees, is 360 over the period. Our equation of the axis is the max plus the min divided by 2. We need to always make sure that we have 5 key points when we're graphing these, okay? So make sure you put your 5 points on your graph. Now looking at this first example. So we've got a group of students is tracking a friend, John, who is riding a Ferris wheel. So this is the classic Ferris wheel question. They know that John reaches the maximum height of 11 meters at 10 seconds and reaches a minimum height of 1 meter at 55 seconds. Develop an equation for the sinusoidal function that models John's height and determine his height after 78 seconds. So we're going to put on our important pieces of information, which are that we are at a maximum height of 11 meters at 10 seconds, and a minimum height of 1 meter at 55 seconds. So we go to 10 seconds, so we're counting by 1, go to 11, whoops, that's 5 seconds. So we want to be at 10 seconds and 11 meters. Then we want to go to 55 seconds and go to 1 meter. Now counting the boxes between these two spots, I know I'm at my minimum and my maximum. Halfway between them I need to be at the halfway point. So if I have 1, 2, 3, 4, 5, 6, 7, 8, 9 spots, I have to be 4.5 spaces to get in between. Or 55 minus 10 is 45, divided by 2 would give me my 4.5. So my midpoint, and we're going to be 1, 3, 4, 5, 6, 7, 8, 9, 10 down, is going to be 4.5. Right there. My other midpoint, I'm just going to count by 4.5 now. 1, 2, 1, 2, 3, 4.5, up 5, 1, up. So there's my general graph. It's going to look something like that. All right. Now we need to put an equation for this graph. So I always use sine functions, and that's just a personal preference when I'm doing these. But this one sets up pretty good for a cos function because of where we start. So if we did this as a cos function, we're going to have our y equals cos bracket, close bracket. Now this is kind of similar to what I was doing yesterday. I've put up that skeleton equation. Now I like to put in my plus 6. I like to put my equation of my axis in first. Then I can count up to the top from that or down to the bottom and find out my amplitude is 5. Now looking at this, I know that my full period is 90 seconds. So if we do 360 divided by 90, we get 4. And now we're going to start at x minus 10. So there's our equation. Now really, for this equation, y is actually my height, and x is my time. So when we look at where is he at 78 seconds, we just plug in our are 78 for the time. Minus 10 plus 6. Be careful with your bed mass when you're doing this, but you should get, just putting this into my calculator here, you should get 6.2 meters.